Welcome everybody. Trust you've all had lunch. This is going to be one of those rare events where you get to keep your mobile phone on, although we will of course ask you to keep it silent. So I'd like to welcome you to the University of Melbourne 3-minute thesis competition final. Now for those of you who have been to some of the semi-finals and the earlier parts of the competition, you'll know that we're in for quite a treat. Personally, I'm hoping we'll hear something about hair loss. You never know. There's some good researchers in the room. My expectations are high. I want to particularly welcome our judges who are sitting down the front, who I will introduce in a few moments. Also our 10 finalists who are also sitting down the front. They seem particularly relaxed, I might say, although I have noticed that a couple of them have got little hip flasks and they've been taking a few, but they're doing well. They're doing well. In particular, though, I would like to acknowledge the traditional custodians of this land. I'd also like to pay respect to the elders, both past and present, of the Kulin Nation and extend the respect that we give to them to other Indigenous Australians that may be present. On that note, I would like to introduce to you Professor Dick Strugnell. Now, Dick is our Pro-Vice-Chancellor of Graduate Research, and he's going to tell us a lot more about this particular competition, about research at Melbourne, and about what you're going to be seeing in the next hour or so. So, Dick, if you wouldn't mind.
It's a very odd feeling without a lectern here, but first of all, welcome everybody. This is a real highlight on the MSGR calendar, and we hope in the future for the university as well. Before I start, I just want to thank the 3 people that have really put this day together, because I think they may get lost in the celebrations later. And Susan Dazier, who's sitting quietly behind the screen here, unobtrusively spent weeks and weeks putting this together, putting the heats together and the finals together, making this day possible. So I want to pay enormous homage to you, Susan, for doing that. And your offside is Sylvia and Marcus, wherever they are hiding down here. Okay. Can you hear me up the back? Yep. So universities in Australia are largely publicly funded institutions. And I think for the public, they can see what the university produces at the coursework level, at the undergraduate level and the postgraduate coursework level. They can see our graduates going into industries and other things. It's less tangible, I think, for the public what we do in the 3rd cycle of the university, that is the research training cycle, and in the research environment. And I think part of our obligation in taking funds from the public, the audience if you like, is to be able to communicate back to the public what we're doing with those funds. And so a very important driver for the 3MT competition is communication, and a communication to a lay educated audience about what you do as a graduate researcher, the front row here, from day to day. And so that's really the driver behind the 3MT competition. It had its origins originally in the so-called elevator pitch competitions that business schools used to run, where the principle was that a young entrepreneur would get into a lift with a CEO, and by the time the lift went from the ground floor to the top floor, the young entrepreneur had convinced the CEO to invest in their company. That sort of very early concept was matured by Alan Lawson, who was the Dean of Graduate Studies up at University of Queensland, into a competition called the 3MT competition, and that's what we have today. And that's the true sort of national exposure to the 3MT started about 3 years ago, and the rules really haven't changed, and that is that every candidate has 3 minutes and no more than 3 minutes to explain their research, the context of their research, the findings of their research, using one slide and no transitions. And you'll hear about the judging criteria and other things in a minute. The winner of today's competition will receive this lovely perpetual trophy that's called the Peter McPhee Cup, after Peter McPhee, the inaugural provost of the University of Melbourne. And Peter, very unfortunately, can't be here today. He was put into hospital yesterday, but he does send his regards, and he holds this competition in very high esteem, and he was very sorry that he couldn't be here. And I sense the whole audience would be with me in saying we hope Peter gets well soon. Okay, well, I'll hand back now to Shane, and Shane can tell you about how this competition is going to be judged.
Thank you, Dick. Gee, I thought I'd have a few more minutes to work out what I was going to say next, but he got through it all so quickly. Now, one of the things I wanted to mention here, first of all, is I don't usually introduce myself at the start of these things because I think there's far more important people that we come across. My name is Shane Huntington. I work here at the University of Melbourne and I do a radio program on 3RRR, and one of my colleagues from RRR will be speaking to you a little bit later. But one of the things that I know is true is that the communication of research is crucial. And we've seen, in some ways, a degradation of the importance of research in society over the last few decades. So seeing these people down the front here coming in and doing this with such skill is really important to the future of research and how the public perceives it. So it's something that matters. In terms of the judging criteria, and I understand we have a slide for this, there are 3 key elements that our judges will be looking at. The first is communication style, the second is comprehension, and the third is engagement. And I think, I'm not sure, they're facing the front, but for the engagement part, I'm sure they'll turn around and make sure no one's nodded off. But it is key to what we do. Now, our judges today are very prestigious people that some of you, many of you, will know very well. First up, sitting in the middle, is Professor Sue Elliott, who is our Deputy Vice-Chancellor of Global Engagement. And Sue has had a distinguished medical career and been at the university for many, many years, and we all love her dearly. Next to her is Professor Warren Bebbington, who is the Deputy Vice-Chancellor of University Affairs. And Warren has also had a very distinguished career at the university, and I suspect probably feels more comfortable behind the Steinway than sitting down here, but has been part of the musical culture and the arts culture of this university for many years. And then on the far right is Simon Clues, and I suspect that your link with this competition has been long and in some cases drawn out, and in other cases exciting, and will continue for a long time. Simon is the director of the Writing Centre for Scholars and Researchers at the Melbourne School of Graduate Research. And Simon has been a judge throughout the 2011 3MT competition, through the heats and the semi-finals. I think you've probably heard some of these presentations numerous times and have seen them evolve. And he'll also be judging the National Australian, New Zealand and South Pacific Grand Final at the University of Western Australia in Perth on the 29th of September. And I understand after that there's a Milky Way Grand Final that you'll be doing. They're trying to get you for that one. So incredibly involved Simon has been throughout this process, so we're very happy to have all 3 of you here to be judging for us today. Not having a lectern is tricky here. Now, I also want to make you aware of the People's Choice Award, actually. And there's a slide up here. Now, this is interesting, because this is where you actually, in real time, get to make a selection of who you, the people, think gave the best presentation. And I suspect you can make up your own judging criteria. But as a person who is on radio, please don't make it based on what the person's wearing or how they look. I normally get to hide behind a radio microphone, but I'm sure you'll all have your favourites depending on personal circumstances and interests. It is not that complicated. We will give you instructions later. You all have a sheet of paper, I understand it, with the contestant's name, their title of their talk, and also the code that is required to be sent through via this phone number. Now, in order to prevent you from sitting there and pretending to send SMS messages about this throughout the presentations whilst you're otherwise engaged in other activities on your phones, the judging will not, the competition part of that you're involved with will not start until the judges deliberate at the end of all the presentations. So you'll have about 5 to 10 minutes to cast your vote. You can only vote once, as I understand it, Susan. So don't think that you can send 50,000 text messages to your friend down the front. That won't be the case. You get to vote once and then your number is scrubbed from the list. So that will happen a little bit later. Now, at this point, I think we should get started. So I would like to introduce up to the stage, and she's about to be mic'd up, Ashika Saul, who is going to be speaking about visual attention processes in motion perception. She's from the optometry and vision science part of the university. Ashika, it's all yours. Just for Ashika's benefit, everyone in the competition knows this already, but there will be a bell at 2.5 minutes to indicate that there is 30 seconds left, and then I understand a small explosion after that. So the first bell's at 2.5 minutes? Yep. And then a small explosion at 3 minutes, which will make room for the next contestant. Ashika, over to you.
Let's begin with a game of I Spy. So if you look at this picture taken in Chinatown, I spy with my little eye an ATM. Now, given a bit of time, all of you would be able to spot the ATM right over there. Every moment, we are bombarded with so much of information. Sights, sounds. If we're in Chinatown, yummy smells too. All of which our brain has to process. If there's a problem in the processing somewhere, it could result in serious brain disorders. In fact, 1 in 4 families in this room will have at least one member who has a mental disorder. It could range from dyslexia in kids right up to Alzheimer's in the elderly. Treatment for these sorts of disorders is woefully inadequate. Why? Because in order to understand what goes wrong in a diseased brain, we need to understand what happens in the normal human brain. That is why my research focuses on understanding how the mind works. So what does attention have to do with all of this? When we pay attention, the brain doesn't need to process all the objects in the scene, but just the important ones. How does the brain decide what is important? Decades of research has shown that attention can be guided either by locations or by features. Allow me to illustrate. If I were to provide a hint or a cue that the target, which is the ATM, is somewhere on the right-hand side of this image, then your attention doesn't need to scan the entire display, but just the important part. Voila, you find your target. But there's another possibility. If I instead hinted that the ATM has a red symbol on it, red being a feature, then all the objects with red on them would appear to pop out, and you could quickly scan amongst them and find your target. In reality, however, there's an added level of complexity, because a lot of these objects would also be moving. Cars, people, all in different directions. So in my experiment, I designed a task that was similar to the I Spy game, but instead of having real-life objects, I had a series of moving dots. Participants were either told where the moving target was, or in which direction it was moving, or the color of the moving target. When I compared the effect of each of these cues on performance, I found that location cues guide attention the best. But even with these cues, some of us are better at paying attention than others. So in the next part of my project, I'd like to look at images of the brain to see why is that. I think trying to understand how the mind works is exciting, not just because of the implications in treating disease, but because it helps us understand who we are. The brain defines who we are. So my search for answers is on. Thank you.
Thank you. Fantastic. I can tell you my attention is on the 1 metre drop at the edge of this stage, which I will be monitoring carefully throughout this hour. Our second speaker today, our second finalist, is Katherine Granger from physiotherapy. Katherine's going to be talking about physical activity levels in people with lung cancer. Katherine.
One in 3 of us in this room will be diagnosed with cancer before we turn 75. Lung cancer is the most prevalent type of cancer, and it's also associated with the worst mortality. 5 years after a diagnosis of lung cancer, only about 10% of people are still alive. Therefore, the quality of survival of those remaining years is of utmost importance. Now, lung cancer is normally treated by surgically removing the section of the lung where the tumour is located, followed by a period of chemotherapy. However, the disease and the treatments cause some terrible side effects to the individual, including pain, breathlessness, and fatigue. Often people with lung cancer, compared to other types of cancer, experience much more hardship from the disease and are more frequently depressed. Now, clinically, I see people with lung cancer electively decrease the amount of physical activity they participate in. For example, they stop walking to the shops, or they cut down on the time spent in the garden. Now, this change in physical activity is harmful and it leads to a vicious cycle. By doing less activity, the individual becomes weaker and subsequently can't do more activity even if they wish to. You may ask, well, does it matter if someone with lung cancer becomes less fit? And the answer is yes. Firstly, their quality of life can be affected because they are no longer strong enough to participate in their normal leisure activities like visiting their family and friends. And secondly, important to their survival, they may not be strong enough to complete the desired chemotherapy treatment. Now, as a physiotherapist, I'm very passionate about looking at how exercise can help people with lung cancer. Unfortunately, exercise is not part of normal care provided to people diagnosed with lung cancer, despite the fact it is for many other diseases. My research involves 100 people who have just been diagnosed with lung cancer. During their disease, I am measuring their level of physical activity and a variety of other factors, including their fitness, their muscle strength and their symptoms, to understand how all these factors interrelate. This research project is the first of its kind in the world and will provide us with some very valuable information. The results of this project will enable us to design a tailored exercise program targeting the needs and main problems of people with lung cancer. I hope through exercise training and education regarding physical activity, we can help improve the quality of survival of those living with lung cancer. Thank you.
Okay, we're hearing some great stuff here today already, and we're only 2 down. So third on our list is Johanna Dupain, and she'll be talking about battling the Hendra virus, the search for a treatment. She's from veterinary science.
Hendra virus. 17 outbreaks in the past 8 weeks have been splashed across the news. And you may be wondering, why the commotion? Well, I can tell you why. And that's because Hendra virus kills you. And what's worse, we don't have a commercial treatment against this terrifying disease. That is the purpose of my PhD, to find a treatment for Hendra virus. Naturally, Hendra virus exists in bats. And on the rare occasion, it travels from bats to horses and then to humans. Of 7 human infections, only 3 people have survived. And what this tells us is not only do we need a treatment, but we need it urgently. But where do we begin? Well, my laboratory thinks we may have the clue. Take a look at the slide behind me and you'll notice the broad range of animals that are susceptible to Hendra. However, one particular animal is missing. It's small, it's easy to handle and commonly used in scientific research. So which animal is it? It's the laboratory mouse. It's not included in the slide behind me because early studies told us that the mouse was completely resistant to infection. However, with more detailed work, I've found that some mice can become infected, whilst others are highly resistant. So how does the highly resistant mouse stave off infection? If we can understand how this mouse resists Hendra, we can use this information to help humans do the same. So how do we go about understanding this? Well, we believe that infection is fought off by a critical division or component of the resistant mouse immune system. Now, you can think of the immune system like the body's defence force against harmful invaders such as viruses and bacteria. Like any good defence force, it's made up of several divisions. There's an army, a navy, an air force, and so on. Now, depending on the war that's being fought, one of these divisions may be critical to a victory. For instance, if you removed the navy from a major sea battle, the army's going to find this a very difficult war to win. What we want to know is which division of the mouse immune defence force is critical in fighting Hendra. We can answer this by simply removing one division of the defence force at a time using a gene removal tool called knockout mice. We then ask the question, if the resistant mouse is missing, let's say it's navy, can it still fight infection? If it can't, if it becomes sick, then we know that this is the division that's critical for fighting Hendra in the mouse. With this information, we can seek a treatment that helps the human immune defence force fight Hendra as successfully as it does in the mouse. So perhaps next time Hendra is splashed across the news, it's not for fear of human infection and death, but because the tiny mouse has given us the weapon with which it can be defeated.
Gotta love those tiny mouse. Nice nieces. Our next finalist is Khalid Abu Baker. He'll be speaking about cancer stem cells, the puppeteers of ovarian cancer, and he's from the Department of Surgery.
The war on cancer has been raging on for over 3,000 years. 3,000 years of medical advances, but still, for patients of ovarian cancer, we are prescribing palliative care as the final form of treatment. Imagine losing your loved one to this disease, your mother, your wife, or your daughter. The thought itself is unimaginable, but yet, this is what Australian families are facing every 11 hours in this country. By the time you go home and get ready for bed, that signals the death of someone's mother or someone's daughter, devastating yet another Australian family. I want to share with you an experience that I've had with a previous patient of ours. I will call her Jane for the sake of this talk. Jane was a young mother, 34 years of age, which had ovarian cancer. By the time Jane came to the hospital, the disease had already ravaged her abdominal cavity, growing out of control. She had limited treatment options. It was hope that compelled her to undergo surgery, and it was with hope that she underwent chemotherapy. A short 18 months later, her cancer came back. It came back more aggressive, more invasive, and resistant to everything we could throw at it. And in early 2011, ovarian cancer killed this mother of two. Ladies and gentlemen, we are desperate. We are desperate to find the answer as to why Jane's cancer came back, why it was so aggressive and resistant. And more importantly, how could we prevent the death of another Jane every 11 hours? And these are the questions that my project is trying to answer. So what have I done thus far? So far, my research has come up with 3 leading principles. In our labs, I have seen the existence of what we call a cancer stem cell. This is a special kind of cell that can withstand the chemotherapy and then bring back a tumor that is more resistant. So I asked the question, how? How are these cells able to resist? So I challenged them in the laboratory with various chemotherapy drugs. And to my surprise, they simply shapeshifted. They changed from an organized, column-structured cell to a more invasive, more aggressive, needle-like cell which were resistant. And so I dug deeper. And my results now indicated to me that cell signaling also played a critical role in this phenomenon. So what is cell signaling? Imagine a switch within a cell that I hypothesized that if in the on position, it will push the cancer to keep growing, shapeshift, and become resistant. So I strongly believe that if I can figure out where this switch is and learn how I can switch it off, I can perhaps make the cancer more responsive to chemotherapy. I have a glimmer of hope, my friends. I believe we have found where this button is. And using microscopic drugs, we have partially switched it off, and the results are promising. Indeed, the cancer is now less aggressive, less invasive, and importantly, it is no longer shape-shifting, but instead dying. This is a new dawn. Essentially, my results will hopefully translate to another Jane out there and give her the ability. Thank you.
Thank you, Khalid. Our next finalist is Lauren Gaughan. She'll be speaking about the Lam Yong Yolmo Dictionary Project, and she's from the School of Language and Linguistics.
Ladies and gentlemen, I am a #1 worldwide best-selling author, but you won't find anything that I write on the pages of the New York Times bestsellers list because I'm a best-selling author in a language that had previously never been written down. That language is Lam Yong Yolmo, spoken by only around 700 people who live in the foothills of Nepal's Himalayas. For my PhD project, I'm writing down the grammar of their language for the first time. I was interested in this project for 2 reasons. The first is that this language has a very subtle and complex verb system. So to give you a brief example, where English has the one little word is, Lamjung Yolmo has 4 different options to choose from. But there was a second motivation for me wanting to do this work. You see, Lamjung Yolmo speakers are on the bottom rung of Nepal's caste system, and as people move away to find work and the children are now being educated in Nepali, these people have fewer and fewer opportunities to use their own language. Which means that within the next 2 to 3 generations, it's unlikely this language will be spoken at all. But a fusty academic grammar written in English is hardly going to be a bestseller for Lamjung Yolmo speakers. So instead, what they asked me to do was help them write a dictionary. I'd already been collecting word lists for my own work, so together we sat down and devised an alphabet based on the existing Nepali alphabet, and the Lamjung Yolmo English Nepali Dictionary was born. Now, it's still really small with only a couple of thousand entries, but this is the first time these people have seen their own language in a book. But what would an illiterate person like my friend Asa want with a dictionary? You see, for someone like Asa, this dictionary is a powerful symbol that her language is as important and tangible as a major language like English or Nepali. But now the dictionary isn't the only book that we have in Lamjung Yolmo. On my last field trip, I had with me some picture cards of a story called The Jackal and Crow. And I was trying to get some good storytelling recordings, and the kids loved these pictures so much that I sat down with a couple of them, and together we wrote the story out. To be a best-selling author in a previously unwritten language only takes a couple of dozen photocopies, but this is the first time these children have had an opportunity to practice their newfound literacy skills in their own language, which is something that's unthinkable for English speakers. This work has also had positive implications for my own work as well. It's allowed me to get a lot more subtle and complex, culturally specific terms than I ever would have without also doing the dictionary. As a very flippant but I think important example, I now have at least 8 different words for basket in the current version of the dictionary. This project is unlikely to single-handedly stop the declining use in Lamjung Yolmo. The dictionary and the picture book, however, are powerful tools for these people to allow them to realise how important their language is, which is as much as any author could hope for, bestseller or not. Thank you.
Okay, we've reached the halfway mark. Now, back in my day when I did my PhD, and if you want to work out the vintage of when I submitted mine, it was a really, really good wine year that year. So do the numbers. Really, really good, like one of the best ones. They used to, about at this point, hand out packs of Panadol when people were listening to PhD theses being discussed. Fortunately for us today, we have a higher standard than what was once the case. So we're very lucky. The first 5 have been fantastic, I think, but we have 5 to go. The first of which is Nicola Crema. She's going to be talking about how flies can help us cure cancer, and Nicola's from Anatomy and Cell Biology.
We all know cancer kills on a large scale, but what you may not know is the solution may lie in the little fruit flies that you see buzzing around your very expensive ripe bananas. These fruit flies have the potential to help cure a disease that has killed more people than war and more people than natural disasters. These are some impressive fruit flies. These fruit flies are used by scientists, including myself, for medical research. Why, you may ask? Well, fruit flies use the same genes that we do to develop into adults. So studying these flies has helped us to understand how our cells work and has led to many important discoveries. What is rather astonishing is that 75% of genes responsible for human disease are also present in fruit flies, even though we are separated by around 700 million years of evolution. So whether a cell is from a fly, a mouse, or a human, it has a basic set of signalling systems, or its hardware. This hardware runs the software or the programs of development that will produce, for example, a wing in a fly or an eye in a human. So I work on a gene called MYC. It is a gene that we all have, and the cells in our body use it to function and to grow. And it works exactly the same way in fruit flies. Cancer happens when genes are damaged. When the MYC gene is damaged, it becomes unstable, rather like removing some of the piles from underneath a house. This instability causes cells to grow out of control, and then a tumour is formed. This MYC gene is damaged in the majority of human cancers. It is critical to understand how MYC works if we want to stop this from happening. Now imagine if a gene whose job is to make a cell grow isn't switched off. What happens? The cell just keeps growing and growing, which ultimately forms a cancerous tumour. MYC, if damaged, is a potent cancer-promoting gene. I'm interested in two proteins that we think may control its activity. One, which may be switching MYC on, and another, which switches MYC off once it has done its job. I'm also working to uncover the mechanism in which they do this. So if I can determine how these proteins control MYC, the cancer-promoting gene, we can work toward developing a specific treatment that will stop this gene from causing cells to grow out of control and forming cancer. So next time you see a fruit fly, and as you're swatting it away, remember that fly has the potential to save your life.
There are just too many fly jokes to choose from, so I'm just going to move on to the next speaker. Chris Leung is from the Department of Medicine, and Chris is going to be talking to us about, is our diet ageing us, the role of AGEs in fatty liver disease.
There is a silent epidemic of fatty liver disease in Australia. In fact, half of you in this room and half of you viewing out there on the internet will have fatty liver disease. Fatty liver disease, or too much fat in the liver, is bad because it can progress to inflammation, which then can progress to scarring of the liver. And as Darren Hinch can attest to, one of the major complications of scarring of the liver is liver cancer. In fact, 1 in 20 people with fatty liver disease will get liver cancer after 15 years. Despite this, there are currently no therapies for fatty liver disease, and all I can tell my patients is to exercise and have a good diet. But even my dietary advice is incomplete. So in my PhD, I am exploring the role of compounds in food called advanced glycosylation end products, or AGEs. AGEs are formed when you heat protein and sugars at high temperatures. So if you boil foods, you get a relatively low amount of AGEs. But if you bake or fry foods, you get a higher amount of AGEs. And interestingly, if you barbecue foods, you get the highest amount of AGEs. So in my experiment, I took 3 groups of rats. The first group of rats had normal livers. The second group of rats had fatty liver, which I induced by altering their diet. The third group of rats had fatty liver and also a diet high in AGEs, which I produced by baking their diet. In short, I was their master chef. And in just 6 weeks, the rats with fatty liver and a diet high in AGEs had more inflammation in their livers and also trends towards more scarring in the livers. And if you took the cells which produce scar tissue and exposed them to AGEs, they were more activated. So in short, if you have fatty liver, then a diet high in AGEs is bad for you. This finding has huge implications in the way we process our foods and also the dietary advice we give people with fatty liver disease. But because I like my steak char grilled and not boiled, we are now developing ways to block AGEs so that we can enjoy the foods we love, but more importantly, pave the way for brand new treatments for the most common liver disease in the world, fatty liver disease. Thank you.
Am I the only person who's hungry? I mean, I hope that stuff works out because I love my barbecue. Okay, our next speaker is from the School of Population Health. Her name is Patricia Campbell, and she's speaking about preventing whooping cough in vulnerable infants.
In the next 3 minutes, another person in the world will die from whooping cough. You might think that's simply because not all countries have good access to vaccination, and that's a big part of the problem, but it's not the whole story. When developed countries, including Australia, first introduced whooping cough vaccination more than 60 years ago, the impact was colossal, with cases reducing to less than 1/10 of their previous number. But we didn't wipe it out, and now many countries with long-standing vaccination programs are seeing cases increase again. Typical whooping cough starts with non-specific symptoms like a runny nose or a mild fever, which then develops into uncontrollable spasms of coughing, gasping for breath, and vomiting of mucus, seen here. Children, especially those less than 6 months old who are too young to be vaccinated, suffer the most severe symptoms, including nearly all of the deaths. But not all whooping cough infections are severe. Some are mild, and many have no symptoms at all. If you've had a cough that's lasted for more than 2 weeks, there's a 20% chance it was whooping cough. So what makes this disease so hard to control? Well, it's difficult to diagnose. It's infectious long before whooping cough is considered as a cause, and immunity doesn't last forever as we used to think. In Australia, we usually see peak numbers of cases every 3 or 4 years, but since 2008, our cases have skyrocketed, and I want to find out why. My research aims to prevent whooping cough in infants who are too young to be vaccinated by improving our understanding of what spreads this infection in our population. We're using mathematical models to do that. We divide the population into people who can be infected with whooping cough, people who currently are infected with whooping cough, and people who cannot be infected with whooping cough. And we consider the events that move people from one group to another, like infection or vaccination or wearing off of immunity. We keep track of the numbers in each of these groups over time when we make a change, like starting or stopping vaccination, and compare the outcomes to see which is the better option. We hope that our findings will help decision makers in Australia identify better options for controlling whooping cough and improve global understanding of what spreads this disease, because one death every 3 minutes is one too many.
Okay, we have 2 to go, so 8 down. Our next speaker is Rosemarie Boland. She's going to be speaking about the power of prediction, and she's from the Department of Obstetrics and Gynecology.
The birth of a baby is normally a joyous occasion, but for 1 in 12 families in Victoria this year, that joy will be overshadowed by fear and uncertainty because their baby will be born prematurely. Babies like Molly, born 4 months prematurely and weighing just 500 grams, the weight of a tub of margarine. And the parents of these tiny babies always ask the same question: will our baby survive? If only I had the power of prediction to answer that question. I don't, or not yet, but I've started working on it. When it comes to predicting a premature baby's chance of surviving, there are certain things we can tell the parents. The earlier the baby's born and the less the baby weighs at birth, the greater the risk the baby won't survive. We also know that if a mother gives birth to a very premature baby in a perinatal centre, which is a specialist maternity hospital with newborn intensive care facilities, that this increases her baby's chance of survival quite significantly. In fact, for some babies, it doubles their chance of survival. So perhaps you're sitting there thinking, isn't the solution obvious? All very premature babies should be born in a perinatal centre. And of course you're right, but there are only 3 perinatal centres in Victoria, and all 3 are here in Melbourne. So what would have happened if Molly's mother had gone into premature labour 500 kilometres away in Mildura? We would have had to try to move her to Melbourne before Molly was born. But time and distance aren't always on our side in these situations. Sometimes there simply isn't enough time to move the mother before she gives birth. And other times, the very real risk that she could deliver a tiny premature baby in a helicopter or ambulance on the way is simply too great to contemplate moving her. So for every 7 mothers who do give birth in a perinatal centre, there'll be 1 mother who doesn't. But what makes this mother different? And why does her baby have less chance of surviving? These are the questions I'm trying to answer. You see, for years I've thought maybe it's not about where the baby's born, but the circumstances surrounding their birth. Maybe these mothers have other risk factors that make their babies more vulnerable. And maybe, just maybe, some of these risk factors are preventable or treatable. So my research, the prediction study, is trying to identify these risks. And I'm doing that by analysing data from more than 15,000 mothers who've given birth to a premature baby in Victoria. And in the end, I hope we will have the ability to better predict the woman at risk of giving birth in the wrong place and at the wrong time and prevent it, because this would save babies' lives. 4 months after she was born in a perinatal centre, Molly went home. I hope my research will help many more babies like Molly go home. Actually, it's more than a hope, it's my prediction. Thank you.
Okay, lucky last. We have Tommy Liu, who's going to be speaking about knocking the socks off arthritic mice. He's from the Walter and Eliza Hall Institute, which some of you may call WeHi. It does have a longer name though. Thank you, Tommy.
Arthritis is the major cause of chronic pain and disability in Australia. Nearly 1 in 5 Australians suffer from arthritis. Nearly 1 in 5 will experience difficulty in performing the most important daily tasks, such as walking, cooking, or updating your Facebook status. But arthritis is not a single disease. It is a term that encompasses over 100 ailments that affect the joints. 3 of the most common are osteoarthritis, rheumatoid arthritis, and gout. The symptoms of arthritis include pain, swelling, and stiffness in the joints, which can be temporarily alleviated by anti-inflammatory drugs. However, these do not halt the progressive destruction of the joint. Aside from complete joint replacement, arthritis is not yet a curable disease. Current research into arthritis has focused on the white blood cells, those of the immune system that defends the body against infectious diseases and foreign materials. This is because we already know those cells are involved in inflammation. My project, however, is focused on the biology of the cartilage itself. In a normal joint, cartilage is a smooth and strong material that lines the connecting ends of bones and acts as a cushion during joint movement. In an arthritic joint, erosion of cartilage can lead to situations where bone is literally grinding against bone. Interestingly, there is only one cell type in cartilage, called chondrocytes. Chondrocytes can make proteins that maintain cartilage health and also have the ability to remodel cartilage. It is commonly believed that chondrocytes are only bystanders in arthritis. However, we believe chondrocytes can both initiate and maintain inflammation in the joint. So where do we begin? Well, there are proteins made by some cells that act as off switches for the immune system, where they can turn off inflammation after it's begun. SOX3 is one such protein. We developed a mouse with SOX3 specifically removed from chondrocytes, and by removing this inflammatory off switch, we amplified all the processes chondrocytes are involved in, highlighting their role in disease. We found that these mice developed more severe inflammatory arthritis, and that their chondrocytes produce more proteins that could break down cartilage itself. This is previously unreported evidence that suggests chondrocytes can directly contribute to inflammatory arthritis. And in the context of cartilage biology and arthritis, we now have a target, understanding of which stimulants makes these cells tick, and by the end of this project, how we can manipulate chondrocytes to improve cartilage health. Thank you.
Okay, so we've heard from them all now, and there was nothing on hair loss, which is disturbing. However, I'm sure you'll agree that we're all going to watch what we eat, what we do, think more fondly of flies and mice, and a whole lot of other things that we should be worried about for the next coming years. But we have some great researchers working on a range of these particular problems. We have to give our judges now a little bit of time to contemplate the outcomes, and today there will be 7 runners-up and a first, second and third place awarded for the final. And while we're doing that, originally I thought about trying to summarise some of the things that we'd heard today, but I think given the standard that we heard today, it would be somewhat misplaced for me to do that, because each of these finalists has given you such a clear and concise version of their research. And although on radio I do this all the time, I would hate to paraphrase what they're doing, because I think they've done a much better job than I could ever do. So please join me in thanking all 10 of them again for giving us a fabulous performance. Okay, folks, we might continue. Sorry about the wait. It takes a few minutes to print out those giant novelty checks. And, every good competition has to have a giant novelty check, and this one's pretty big. So what we're going to do first is reward the runner-up prizes, of which there are 7, and then we'll give out the third place, second place, and of course the one we're all looking forward to, which is the winner for today. Thank you. So our first runner-up, and these are in no particular order, I might add. In fact, we've even reordered them so that these people who are sitting in a very specific order down here don't realise who we've missed. We're not a professor for nothing. Right. First up is Patricia Campbell.
Well done, you get a certificate here. And I'll give you one of these after, but we won't show it, so. Yep. We'll get there in the end. All right.
You've got to push these professors around. Our second runner-up is Tommy Leung.
He's a professional.
Trying to get the impression someone's done it before. Our next runner-up is Katherine Granger. The next runner-up is Caleb Abu Baker. Okay, sorry, I have to have a quick peek, see what's happening. It's like election night. You never know. Early polls, I say. Early polls. Don't trust them. Anything could happen. Our next runner-up is Lauren Gawn. I think I've managed to give him about 5 paper cuts in the last 2 minutes. And our final runner-up for today, before we go and announce first, second and third, is Nicola Crema. Okay, now can I ask Dick to please collect the third place medal? Now folks, I have to say, I have the scores here that each of our finalists are being given today, and between first and 10th, there is not much room. So our judges have done a fantastic job separating them because the scores are very close. And so all of you sitting down the front, you should feel very proud of your performances, because I think it was a hard decision in some way to get 3 out of you that were better than the other 7. But you know, you're all finalists for a very good reason. That is, you've done a fantastic job up until now. So congratulations on that. I've lost him. It's the bronze one. You good?
Yes, we're good.
We're good. In third place today, big round of applause, please, for Chris Leung.
Thanks very much. Thank you. You want to leave the winners on the stage? Yeah. Okay. The winner is by virtue of who the runner-up is.
Not sure I want to announce this one, because then you'll know who's won. So you have to hold your excitement until they walk up, okay? In second place today, in our final, is Johanna Dupain.
Well done. Really well done. Thank you. Very good. Very good. A final opportunity. Thank you.
Have you worked it out? I think she has.
She's got nothing.
Our first place winner today, and the winner of the final here at the University of Melbourne, is Rosemarie Boland.
That's so something really inappropriate. Oh, it's a mistake.
No, it's not. There was one runner-up, though, that didn't get announced. I'm blaming Professor Dick Strugnall. Ashika Biggies, congratulations.
Sorry about that.
Oh, that's okay.
And finally, of course, we do have to give, and it is a very big check, and I mean that in both the financial and the size regards, and the perpetual Peter McPhee trophy, which means, of course, that we get it back. Dick, if you will.
Yes. And have you announced the prize values?
It's on the check.
Is there going to be champagne in here?
Can you manage that?
It's a $4,500 check if you can't read that from the very back. We made it as big as we possibly could.
Wow.
Now, I'd like now to introduce a colleague of mine from 3RRR, Jacinta Parsons, who's going to come up and talk about the People's Choice Award. I know she's very excited about this. She's been watching from down there in the stalls as it has been progressing. Jacinta.
It's not entirely going to be a surprise, but we'll try and act shocked when it happens. Thank you so much for inviting me to come along today. I'm representing 3RRR Radio. We're very proud to be connected to the People's Choice Award because we're also really interested in making that connection between what happens inside universities and also trying to connect the public to that story. So we have a research, a PhD candidate that comes on every fortnight to try and talk to me, the public, the layman, and explain research that will then reach thousands of people out there that kind of get to find out all the amazing things that happen inside these walls. Congratulations to everybody. It was excellent to be here today. And I'm ready to announce the winner. Are you ready? Okay, are we ready? I'm not looking at you, Tommy, but it's Tommy Lou. Congratulations. Very good. That's a good one. That's all right. Do you want to go
No,
in?
no.
You're the professional.
I'm not the professional, clearly.
Okay, good. Thank you.
Take that, please. Yeah, I'll hold it. No, you hold it. Yeah.
I think our finalist today just worked out that we gave him a wooden iPad. Some of you may have read that story, but anyway. Look, before we go, and we are going to invite you all to have a coffee back at Dick's house. Is that right, Dick? Is it at your house?
That's right.
It's at your house. But there's just a few people that we'd like to thank particularly, and these are people who judged throughout the competition, who not necessarily were here today, but throughout the competition gave a lot of their time to help the contestants through and give them feedback at every stage. And they were Kerry Newbold, Richard Sellis, Alicia Jenkins, Marshall Lighthouse, Stuart Wythe, Ian Van Driel, Jennifer Closter, Anne Turnley, Simon Clues, Dick Strugnall and Jason Gaber, and all of them have helped immensely with this contest, and I know that our finalists have appreciated their advice all the way through the competition. In addition, the University of Melbourne's Knowledge Partnerships Group has supplied a Cultural and Community Relations Advisory Group grant to help support this program, and of course the Melbourne School of Graduate Research and the Writing Centre for Scholars and Researchers have been immensely helpful in putting this on today. So if you just join me in thanking them, our judges today and all our contestants.